Welcome children to this session. In this lesson children, we have seen the theory part. We have seen all the laws of Newton and the concept like momentum, inertia. These are the things that we have seen. Today we are going to discuss some of the question and answer part which are there in the textbook, not in the exercise part, in between the text in the lesson itself, and we are going to solve some of the exemplary sums that are given. You can take down your notes children. These the question and answers that I discuss now, I will be giving you the complete notebook children, complete the answer part I will be giving you regarding these questions. You can listen carefully and make a note if it is needed, but you need to write down the question and answers or the sums that I solve on the board children. To begin with, let me take the page number 118. The questions 4 are there. The first question: which of the following has more inertia? When we discuss regarding inertia, inertia of a body is directly proportional to mass. The first question: a rubber ball and a stone of same size. If we compare these two, rubber ball and a stone will have more mass, therefore inertia of the stone becomes more because of mass. B, a bicycle and a train. Train is the answer, which has got more mass, therefore inertia becomes more. C, 5 rupee coin and 1 rupee coin. 5 rupee coin has got more mass, therefore inertia of the coin, 5 rupee coin, becomes more. Second question children. For this, I will be giving you the notes, you need not to worry children. Only the sums you need to copy down. The second question: in the following example, try to identify the number of times the velocity of the ball changes. The description is like this. We need to find out how many times velocity changes. A football player kicks the football to another player of his team. Let us take the diagrammatic representation of this easy way of doing this. Let me consider. This is the ball which is kicked. Okay, it comes to another player. So player A, player B, he has kicked it. The agent, the force applied is a kick. So first time its velocity changes. It was at rest, its velocity changes. It reaches B. It reaches B. Then a football player kicks the football to the another player of his team, who kicks the football towards the goal. He kicks the football towards the goal. Goal they have taken. So again here the agent is a kick. Second time velocity changes. What he does, using his hands, he stops the ball. Okay, the force applied in this is the hands are used to stop the ball. Stopped. Ball is stopped. Ball is stopped. The force is this. Here again the football comes to rest children. Therefore, third time the velocity changes. The fourth time again collects the football and kicks it towards the player of his own team. Again he kicks the football towards his team. Let me consider this as C, and he kicks it, the agent. So fourth time velocity changes. So there are 4 times the velocity of the ball changes. And the last part of the question: identify the agent supplying the force. In the first case, the agent is a kick by the first player. Second force is applied to a kick. The goalkeeper uses his force to stop the ball by hand. The velocity comes to 0. Again he kicks it. The agent is a kick. So these are the 4 ways by which velocity of the ball changes. The third question, children. Explain why some of the leaves may get detached from the tree if we vigorously shake its branches. See, children, the first part of its answer is why the leaves fall when a tree is shaken. The first part of the answer is due to inertia of rest. This is the first part. Explanation comes second part. What is that explanation? Usually, children, the leaves of a tree will be at rest, state of rest, inertia of rest. When a tree is shaken with a greater force, the branches also move. Along with the leaves also move. Previously, the leaves were at rest. Now the leaves are in motion, due to which the leaves get detached and fall. The answer is very simple. It is due to inertia of rest. The fourth one. Why do you fall in the forward direction when the moving bus brakes to a stop? First part. Second one. We fall backward when it accelerates from rest. The first part of the question. When we are moving in a bus, we too will be in the speed of the bus. When the vehicle suddenly comes to stop by applying the brake, our body tends to move in the state of motion, because of which we tend to fall forward. This is due to, first part is due to inertia of motion. Second part of that question, children. You are sitting in a vehicle which is at rest. Suddenly vehicle starts to move, we tend to fall backward. This is due to inertia of rest. The vehicle is also at rest. We are also sitting in it, we are at rest. When the vehicle moves, our lower part of the body moves along with the vehicle, therefore we tend to fall back. This is because of inertia of rest, children. This is about in this page 118, children. Now we are going to discuss the sum number 9.1, page number 120, for which I have written the given, children. Given I have written. There are 2 conditions in it, children. Whenever you work out the problem, children, you must know what is given. Write down the given neatly. If it is necessary, write down the diagram, that will help you better. There are a number of concepts that we learn when we solve sums based on the particular concept of the lesson. Given to be written, children, we must know what to find out, for which is the very appropriate formula, substitution, simplification, and keeping the answer with the particular essay unit. These are the steps to be followed, children. Now, let me read out the question. A constant force acts on an object of mass 5 kg for the duration of 2 seconds. It increases the object's velocity from 3 meters per second to 7 meters per second. Therefore, initial velocity is 3, final velocity is 7 meters per second. Find the magnitude of the applied force. What is the quantity of the force applied? Question mark. Second part. If the force was applied for the duration of 5 seconds, what would be the final velocity of the object? See, children, it is easy sum, children. Mass, time, initial velocity, final velocity, force to be calculated. This is based on Newton's second law of motion. We know that F is equal to mass into acceleration. You will write down one by below the other children. I write here, mass is given children. Acceleration, the rate of change of velocity, v minus u by t. V minus u divided by t. All the parameters are given children. So, if this will be mass is 5 kg, final velocity is 7 minus initial velocity is 3, time taken is equal to 2. This will be equal to 5 into, this becomes 4 by 2, 1 time, 2 time, this will be equal to 10 Newton. Therefore, 10 Newton of force is applied on an object of mass m so that its velocity has changed from 3 to 7 in a duration of. Now, if the same force is applied on the object for about 5 seconds, what will be its final velocity? You will take this formula. Okay? We know that m into v minus u by t is equal to f. Now, you will substitute. Mass is given. Mass is 5 kg. Final velocity we do not know. Initial velocity of the object is 3 meters per second. Time taken for this about 5 seconds is equal to force we have calculated already children. It's about 10 Newton. Remember this 5 ones and 5 ones are get cancelled. Therefore, v minus 3 is equal to 10. Therefore, v is equal to 10 gets transposed. Therefore, plus 3 children, v will be equal to 30 meter per second. So, this will be the final velocity of that object. It's very easy children. We must know what to find out. Application of the formula. A can be written as like this, whereas A is given in terms of this substitution and finding out. Consider this sum children, 9.2 page number 121, which would require a greater force. There are two cases again. Accelerating 2 kg of mass at 5 meter per second square. Object whose mass is 2 kg, acceleration becomes 5 meter per second square. Another situation, mass is about 4 kg and acceleration is about 2 meter per second square. In these two cases, in which case the application of the force is greater? Very easy to calculate children. First, we shall calculate F1 using the formula F is equal to m into A as per Newton's second law of motion. This law gives the relationship between force, mass and acceleration. The acceleration is produced in the body is directly proportional to the applied force and inversely proportional to the mass. Therefore, F1 will be equal to m into A is equal to mass is 2 kg, acceleration is 5 is equal to F1 is 10 Newton. Similarly, F2 will be equal to mass into acceleration children. Second law, mass is about 4 kg, acceleration is 2, therefore 8 Newton. So, in this, therefore, a conclusion becomes F1 is greater than F2. In this first case, the application of force is greater. Look at this, some children. 9.3, page number 121. A motor car is moving with the velocity of 108 kilometers per hour. Its initial velocity is written. Remember the unit that they have mentioned, kilometer per hour. Therefore, we need to convert it to meter per second. It takes 4 seconds to stop. 4 seconds. In 4 seconds, vehicle comes to rest. Therefore, after 4 seconds, its final velocity will be equal to 0 kilometer per hour. Remember, children, after the brakes are applied, calculate the force exerted by the motorbike if its mass is about 1000 kg. The given we have written, children. Time taken, mass, final velocity after 4 seconds it comes to rest. It's important, given, children. We need to convert the initial velocity 108 kilometers per hour into meter per second. We know how to calculate them, children. Is equal to 108 into kilometer. 1 kilometer has got 1000 meters, children, by 1 hour has got 60 minutes into 60 seconds. 60 into 60 seconds. 3600 seconds. Now 10101010. This is 3 times 2. This is 5 times 2. Again, these two numbers are divisible by 3. 1 times 3. This is 3 times 9. 1 remains 18. 6 times. Again, 1 6. This is 6 times. This will be equal to 5 6 30 meter per second. Given, children, we need to calculate force. Very direct one, children. We will start with F is equal to M into A. I'll write it here. You continue below. Is equal to M as it is. We know that acceleration is the rate of change of velocity v minus u by t will be equal to mass is given, children. It's about 1000 kg. Final velocity becomes 0 minus initial velocity becomes 30 divided by time taken becomes 4 seconds. This will be equal to 1000 into this becomes just minus 30 by 4. Okay, this is 2 2s are, this is 500 times, again 1 time, 250 times. Therefore, will be equal to plus into minus minus 3 into 25 becomes 75, children. 1020. Remember to write down the unit, children. Okay, otherwise it becomes meaningless. Force is equal to minus, sorry, plus into minus, minus. Two things you have to be very careful. When there is a sign, you have to write down the sign, plus there is a unit. The minus sign says that the force is applied opposite to the direction of a moving vehicle. This is the meaning of minus. Consider this, some children. 9.4. A force of 5 Newton gives a mass m1. 5 Newton of force is applied on an object of mass m1, which produces acceleration about 10 meter per second square, and a mass of m2. Same amount of force is applied on another object of mass m2. Same force, F is equal to 5 Newton, which produces acceleration of 20 meter per second square. What acceleration would it give what acceleration would it give if both masses were tied together? First case, we need to find out the mass of the object. The second case, mass of the second object. We have to add the mass. Then find out the acceleration. In the first case, we know that F is equal to m into a as per Newton's second law of motion. Therefore, m into a is equal to F. m1 mass is kept there itself. M is equal to force is 5 by acceleration becomes 10 by cross multiplication, children. Therefore, mass of the object will become 0.5 kg, half kg, children. From this, directly I will write, children, m2 will be equal to this f by a, which will become, f becomes 5 by acceleration becomes 20, 1 by 4, which is nothing but 0.25 kg, children. One below the other you have to write down, children. Now, I must find out the total mass. Therefore, m1 plus m2 becomes 0.5 plus 0.25. This will become 0.75 kg. For this, the force is the same. What will be the acceleration produced in it? Therefore, using the formula, A is equal to F by mass. F is equal to m into A. What is the amount of the acceleration produced in this? Force applied is the same, 5 by mass is 0.75. Remember the simplification part. There is a decimal point in the denominator, children. After 2 digits we have. Therefore, this must be multiplied by 100. This also must be multiplied by 100 because of 2 digits. Therefore, this becomes 500. This becomes 75. These two numbers will be divisible by 25, children. This is 3 times. This is 2 times 20. Therefore, it will become 6.67. Slowly, if I divide and find out, acceleration will be 6.67 meter per second square. So, there are 3 parts, children. Same amount of force is applied on 2 objects of masses m1 and m2, which produces so much of acceleration in this case, so much of acceleration in the second case. So, the first part we have calculated the mass of the object, first object, mass of the second object. We have combined, the total mass becomes 0.75 kg. What would be the acceleration produced? Acceleration is equal to force by mass. Force is the same, mass is 0.75. Simplification becomes 6.67 meter per second square. So, few sums we have done, plus about 4 questions we have discussed, children. These sums you can neatly write down in your notebook. The question and answer part that I will be giving you as notes, children. Please go through the text once, children. You will come across number of examples and occasions where you will learn these concepts easily. Thank you, children. Have a nice day.